Hello, everybody, and welcome to the Astro Show, place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from an aerospace doctor, get some advice about life from scientists, and find out about what's going on above your head, all in the same place. So we hope that you join us every other Tuesday, second and fourth Tuesdays of each month at 6 p.m. Mountain Time on YouTube, Twitch, and now on Facebook as well. So thank you for joining us today. And don't forget, you can chat your questions on Twitch and YouTube. You can also call in and make a comment, ask a question by using the information that you can see on your screen. So don't be shy, give us a ring. We would love to hear from you. On this week's show, we will chat with Dr. Alana Mcdonald from the Department of Astronomy and Astrophysics at the University of Toronto. Among other things, Dr. Mcdonald is a planetarium and observatory administrator. So we will hear all about that later on this evening. But before that happens, let's welcome our co-stars. First, published author, journalist, and creator of the Space Tourism Guide, it's Valerie Stymock.
Hello, everyone. Great to be back.
Hey, Valerie. Good to have you. Next, assistant professor of physics at the University of Austin at Texas at Austin. It's Dr. Nick Galitsky.
Hi, everybody.
Hey, Nick. I am tongue-tied this evening for some reason. Maybe it was that climbing I did just above my desk to put the blinds up. That's why we were a couple minutes late, folks. There was sun in my eyes and I hung a new blind. There you have it. All right, let's get started with astro advice, life advice from astronomers, astronauts, and other scientists. As always, I will read the quotation and the two co-stars will guess which of the four possible quotators actually said this. So here you go. Science has not yet mastered prophecy. We predict too much for the next year and yet far too little for the next 10. And the four possibilities are Carl Sagan, Neil Armstrong, Sally Ride, and Buzz Aldrin. So I'll give you two a moment to ponder that, and you can make your best guess. Valerie?
You want to go first? Oh, am I going first? All right.
Not sure.
Well, my first instinct was Sally Ride, and my thought was that it was a question about, when will the next woman go to space or something along those lines, someone asking her to predict the future.
Yeah.
So I'll stick with it. I'll say Sally Ride.
Okay, fair enough. I like your reasoning. Very sound. Nick?
I'm going with Carl Sagan just because I can hear his voice saying that. I don't know. It just seems like it would fit.
Oh, yeah. Billions and billions.
Exactly, yeah.
Yeah. The correct answer is, next slide, please. Neil Armstrong. Yeah, that one got me too. I did not think that was Neil, but indeed it was Neil Armstrong. And I don't know, I have divergent opinions about this quotation. Curious about what the two of you think about it.
Well, my first question is, when in his career did he say this?
That is a great question. I am not sure. But Maggie, if you're out there, our operations director, if you want to chat that to us, we can make that known to the crowd. Good question. The picture is a young Neil Armstrong, right? That was I think definitely before his historic moon landing, but he was in his mid-30s or late 30s when he landed on the moon. That we did look up, actually. The youngest person to walk on the moon was like 34. Yeah.
That's fun trivia.
Mm-hmm.
I feel like this question, I'm guessing it came later in his career. That was a good way to frame it, Nick, because to me, it feels like what a NASA administrator would say, someone who's been speaking and to the public about what NASA can do for a long time, because they often have timelines and then don't accomplish them. But then within a decade's timeline, they do accomplish a lot more than people ever predict that they will, or that they even think they will.
See, that is exactly the great irony that I thought in this quotation, right? So I'm thinking, all right, Neil Armstrong, first person to walk on the moon, did it in the decade that was predicted by the president. So I'm wondering if that was like a jab at like Congress or something. So like, even though he phrased it as like science, it wasn't actually directed at science at all. I don't know. That struck me as interesting that he used 10 years for that. And that was the president's prediction that people would actually walk on the moon within the 60s, within the decade. I don't know. That caught my attention.
Yeah, it definitely feels like there's some hidden context and subtext in here. I want to know when he said it and who he said it to and what was the question, because there's a little bit of shade buried in the text, which I think is why I thought it was Sally Ride, because it seems like the same kind of thing she would probably get asked. It's like, how do I predict that,
Yeah, and I think when I'm reading it, I'm also kind of going with like NASA administration and be like, we just had the decadal survey in astronomy, which is setting our priorities for the next 10 years. It's not even, it's what we want to focus on. It's not even what we expect to accomplish, right? And so there's these kind of weird timescales, but there's also just the science ability to predict what is going to happen, and that is, then that would get into stuff that actually happens on decadal timescales like climate, and I think even that's challenging to say what's going to happen. So both on the what we expect to accomplish, funding wise and capability wise, it's hard to predict, right? Where's fusion? Is fusion 10 years out still?
Probably more, right?
Oh, depends who you ask. Quantum computing, versus physical things that will be happening in the next 10 years, which I guess in physics and astronomy, everything's on very long time scales, so that doesn't really make much sense beyond the funding and instrument capability time scale anyway.
Yeah, I mean, it was interesting that you mentioned climate, Nick. That was the other thing that came to my mind as well when I read this. Like, actually, science was prophesizing that for 30 years, 40 years. So I don't know. I mean, I'm not sure I totally agree with Neil on this one. I think science actually does have a lot of predictive power. Why he used the word prophecy, I'm not sure. That kind of threw me for a loop. But I mean, I feel like that's largely what scientists do, right? And, gathering observations and data, coming up with theory based on that, and making predictions for what that actually means for the future. I don't know.
Can also interpret as our short-sightedness, our eagerness to do things here and now, to deliver results quickly, not having as many. That is on a funding side. It is hard to have long-term funding support and have your eye out on these big, much larger projects that take a while. JWST being one of those. We're really happy about it now, but that took several decades and has run a few complaints.
Yeah, it just occurred to me, I don't know if this is true or not. Was there a bad funding year for NASA during the 60s, or were they flush like the full space race? I wonder if there was like a bad 6-month period or something, and this is when he said it. I don't know.
All I know is, well, I do know I've looked at NASA funding curves. You can see the spike around the moon landing. This comet might go well for the current ambitions to go back to the moon. Yeah, we'll talk about getting psyched and building up each presidential term or whatever else, and then no funding, no support comes for the long-term haul to actually make it happen.
Right. Yeah. So yeah, I don't know. I am finding myself being less in agreement with this quotation than I think many of the other ones we've had so far. I don't know. That's just me. Any other thoughts?
I've been racking my brain over here trying to remember the name of a book that I read that says that actually this is very much human nature, that we also, when we set goals, we often set really ambitious goals in a shorter time frame than in a longer time frame. And if we would just think logically what we can accomplish in 1 year and multiply it by 10, we don't actually do that. It's like a logical fallacy. So what we predict we can do in 10 years is way less than if we just did even half of what we predicted in 1 year times 10. So I wonder if that's sort of what he's reflecting. But for the life of me, it's a book about time management, and I cannot think of the name of it. But it kind of teaches you how your brain uses time and misunderstands time in the way that you like plan goals and accomplish tasks. And this sort of sounds like something very similar to that book.
Oh, interesting. Fascinating. Yeah, I don't know, Neil. You haven't sold me on this one.
If only we knew when you said it.
If only. Maggie did look it up, by the way. She posted a chat. She cannot for the life of her find out when he actually said this in his career. So those of you out there who are watching, special prize for whoever can come up with the date that Neil Armstrong actually said this. Send us the date and a reference, and we'll send you a really swell astrophotography print. So there's a challenge to you, audience.
And I thought of the book, if anyone's curious. It's called When by Daniel Pink.
Oh, nice.
It's all about the science of timing.
Cool. Excellent. All right. Well, let's move things along here. We've poked at Neil long enough. It's time for Astro 365, this day and week in astrophysics history. We found discrepancies on when this event actually happened in the history of astronomy. We found multiple references that said October 11th, which happens to be today. However, according to NASA, it was October 13th, 1957, that the Magellan spacecraft was commanded to end its mission by plunging into the dense Venusian atmosphere. And Venusian's just a fun word to say, so I'm going to say that again. The Venusian atmosphere. Way cooler than just saying the atmosphere of Venus. But anyways, that was the end of Magellan. Incredibly successful mission. By the way, the very first deep space probe launched by a space shuttle. It was Space Shuttle Atlantis that launched it in 1989. It was supposed to be launched earlier, but was delayed because of the Challenger disaster in 1986 when that space shuttle disintegrated upon liftoff. But also the first spacecraft, now we're getting back to Magellan, first spacecraft to image the entire surface of Venus. 98% of it, not bad. Their goal was 70%. And so NASA outdid themselves with this mission using a synthetic aperture radar, SAR, to map 98% of the surface of Venus during 5 years of orbiting around the planet. So pretty cool stuff. On the next slide, we've got a picture of the spacecraft itself. I think it weighed something like 7,000 pounds. And then the picture on the right is an area of Venus called the crater farm. So one of the really interesting discoveries from this mission was that most of the surface of Venus was volcanic. So lots and lots of huge lava flows all over the surface. And the resolution that this spacecraft was able to attain was pretty incredible, something like down to like 400 feet of resolution on the surface of Venus. And this is all when it's like well up above the atmosphere orbiting the planet. So pretty cool stuff. So nice job, Magellan. But like so many other spacecraft, ended its days flying into the atmosphere of the planet that it was orbiting. I think the same thing happened to the Cassini spacecraft and Juno, right? Or will happen to Juno eventually.
I love how NASA, a lot of these missions from the, I don't know if we can say the late 80s through the mid 2000s, they had certain mission specifications and then they just vastly outperformed them. That is so delightful. And I'm sure there are lots of engineers who are very proud, and rightly so, of their ability to set a goal and just dramatically exceed it on a scale and in a distance where when something breaks, that's it. You know, one thing goes wrong and that was the end of it. And they did it time after time with some of these missions. It's very, very impressive.
Yeah, it's super cool. And like you say, this was not the only one that went down like this. Voyager spacecraft or some others earlier on, but yeah, very cool stuff. So nice work, NASA, on the Magellan spacecraft. All right, it is now time for the astronomy news trivia game. So we will ask each of the co-stars a few questions of some things that recently happened in astronomy news. And you'll get an opportunity to answer those correctly for a point. And I think, Nick, you are up first.
Cool.
All right, you ready?
Yeah.
Okay. Last week, speaking of flyby missions, last week, NASA released images of which icy moon captured during a Juno mission flyby?
Europa.
Europa! Nicely done, Nick. All right, you got that one quick. You must be paying attention.
Pretty
here.
pictures. I was checking those out.
Yeah, very, very cool stuff. I mean, I am psyched about Europa. I think if there is anywhere in the solar system where there might be life, I'd say under the crust of Europa.
Yeah, time to get that Armageddon team together and throw them at Europa.
Bruce Willis, where are you?
I wonder if he's a flat earther. That'd be ironic, wouldn't it? That would be an interesting piece of trivia. We'll try to come up with that for next week. How many movie stars who have been in like space films are actually flat earthers? That'll be fun. We'll figure that out for next time. All right, Nick, here you go. Number 2. New research out of Montclair State University suggests that the asteroid that struck Earth and triggered a mass extinction may have also created a blank that lasted for weeks or even months.
New research. Let's go with tidal wave.
Oh, you're so close. I'm gonna give you a half a point, and I'll give you a hint, and I'll get you the other half of the point. I'll give you a chance to get the other half of the point. So what usually sets off a tidal wave?
Like an underwater landslide or a shifting of the seafloor.
Which we would call a
Not a landslide.
generic term for all those movements. Very generic.
I don't know. Underwater landslides.
It's an earthquake.
Oh, just generally earthquakes.
Just plain old general earthquake.
Gotcha.
Well, we'll give you half a point for tsunami there.
All right. Well,
all right.
tiebreaker.
Yeah. All right. Last one. A new 3D model of the Cat's Eye Nebula suggests what may lie at its heart.
Oh, how about a pulsar?
Oh, you're so close. I feel like that could be another half point.
Neutron star?
Yeah, no, it's more generic than that, actually. It's a binary star. That's why I can give you half a point, because you got one star out of the two.
All right.
All right. So that's 2 points for Nick. So Valerie, you need all 3 here for the win.
It's never happened.
Oh, come on, you got this.
There's a very hopeful outlook, right?
I mean, the Cat's Eye Nebula, maybe we should just like stare at that for a minute. That is pretty cool, right?
No need to ask me any questions. We'll just stare at this slide.
I mean, for those of you who don't know, the Cat's Eye Nebula is a planetary nebula, similar to more common ring nebula that you've probably seen in all kinds of astronomy TV shows, PowerPoint presentations. You've ever seen an astronomy PowerPoint presentation, everybody uses a picture of the ring nebula.
This is perhaps my ignorance of this particular one. If it's got a binary in the middle, does that mean one exploded and the other wrote it out?
That's a great question. I don't know. I assume that at this point, both stars have got to be white dwarfs. I don't think a star could be much other than a white dwarf after its companion kind of gives up the ghost. Although interestingly enough, I do remember reading something recently that suggested that there was some sort of accretion disk around a white dwarf that looked like planetary formation. So apparently, like, not everything gets stripped away when you have a main sequence star end up as a white dwarf and then becoming a planetary nebula. But anyways, yeah, a gorgeous planetary nebula, and this is basically somewhat what our sun will look like in several billion years after our sun gives up the ghost and casts its outer layers out into space, presumably destroying the solar system, and all that will be left of the sun is a tiny little core that we call a white dwarf. It'll still be radiating some energy, but not much, and the rest of the solar system is toast at that point. But it's like 3.5 billion years from now, so lots of time. But yeah, really, really beautiful objects. A terrible name. They're called planetary nebulae because 100 years ago, when astronomers were first seeing these things, they thought they were planets forming because they're spherical in shape, round when you look at them up in the sky. But it has nothing to do with planet formation. It's actually planet destruction. But yeah, it's when a sun-like star runs out of fuel, and instead of exploding like really, really big stars do, supernovae, they kind of just die with a whimper and more gently cast their outer layers out into space and become planetary nebulae, which are quite beautiful. And this is one of the best. All right, Valerie, that's as much stalling as we can do.
Okay.
Are you ready?
as I'll ever be.
Okay, here you go. A team of scientists proposed last week in the Astronomy and Astrophysics Journal that Uranus may owe its tilt to a long lost blank. Long lost what?
Can I go with moon?
You got it. Yeah, Uranus may have had a moon that somehow was shepherding its eccentricity and then somehow lost the moon, and then it flopped over on its side. It's an interesting hypothesis. I had not heard about that until I saw this article, but apparently that is the deal.
Did they try and predict how big that moon would have to be managing a planet like Uranus?
I did not read that far into the article, but I would say it would have to be pretty darn big.
So there just might be a moon wandering around and we can't see it.
Yeah, I mean, they don't reflect that much light and they're so small. You know, we're basically talking like, you know, a big asteroid out in, and it's not really the Kuiper belt even. It's like, there's not a whole lot going on between Uranus and Neptune.
Right.
Yeah, but that's the deal. So nice work. You got yourself a point there. Okay, here we go. Next one. Which SpaceX rocket launch was aborted last Friday evening and rescheduled to Saturday?
Was that Crew 5?
No, it wasn't Crew 5. We're actually just looking for the name of the rocket here.
Oh, it was a Falcon.
It was a Falcon. You got a half point.
They did 3 launches in such a short span of time.
They did, yeah. They were like blasting them off one after the other. I'll give you a hint. It's less than 10.
Oh, it's Falcon 9. Okay, sorry.
Falcon 9.
There's only 2 choices, and they only launched one of them once, right? Twice,
Yeah.
maybe.
Okay, all right. You're all tied up with Nick. Here's your third one for the win. Valerie, are you ready?
Ready as I'll ever be.
Here we go. October 10th, yesterday, 1967, marks the day the International Blank Blank Treaty was ratified.
Okay, I'm gonna just take a stab in the dark of things that people would agree on in space. And is it space neutrality?
You got half of it. It's even more general.
Universal neutrality?
No, I mean neutrality is too specific.
Oh, is it just peace?
It's not even that specific.
Oh.
It's just the International Outer Space Treaty.
Okay, yeah, no. Well,
Yeah.
what is that even agreeing to? You gotta put it in the title.
I have no idea. I did not take the time to read that. But you got a half a point there because you got the word space. So
I hope it's about space.
That makes you this week's champion, Valerie. With 2.5 points, edging it out there at the end. Oh, nicely done. And we had a few more questions for Danny, but unfortunately, Dr. Danny couldn't join us. So we'll
Should we do them,
questions.
Nick? We can just do like Jeopardy style.
We could do Jeopardy style real quick. All right, let's do it. All right, here we go. Just you're gonna have to just like yell louder than the other person first. Here we go. An experimental payload from SpaceX competitor blank will launch in December to test 5G cell phone service from space.
Oh, I just looked at this one.
Is that like OneWeb or something?
Nope. Think of what actually Starlink launches. It's half of that. Or what SpaceX launches. I just totally gave you the answer. Think of half of what SpaceX launches, and that's the name of this company. Starlink is what SpaceX launches. This company is called
Link?
Link. There you go.
Got there. Good job.
They're just keeping things
This is
simple.
more like a word puzzle today than an actual space trivia quiz.
Okay, this one is more a scientific. This one I'm not going to be able to give you a hint on. You're just going to have to know this one. This is, I guess, not really a Nick's field, but maybe. Here we go. A New Zealand Research Institute and U.S. commercial film called a NanoRacks are teaming up commercial firm, NanoRacks, are teaming up to send a novel thruster that uses superconducting blank technology to the ISS.
Oh,
Superconducting blank.
oh no, magnets?
Magnet!
Oh, is that what I
Got
was
it.
thinking? I was like, do magnets conduct?
They do, yeah.
Could they superconduct?
They do superconduct, yeah. You can
Oh
like,
man.
yeah, you can
Balance
like get
like
magnets to
superconducting
like,
wires that form a magnetic field, but sure.
yeah. Okay, last one, here we go. Which company launched a wildlife data collecting satellite mission, charmingly nicknamed "It Goes Up From Here"?
Was it Rocket Lab?
Rocket Lab!
They always have the best
Nicely
mission names. That's how I know
done.
it's them.
Yeah. Yeah. So do you know the name of the system of satellites for a bonus point?
No.
It was in the question, actually. It was in that little.
Is it
saying
Argos?
Argos. You got
Okay.
it. Nicely done, Valerie. Nicely done. All right. Well, that was fun. So we'll do that from now on. If we have leftover questions, we'll just rattle them off Jeopardy style there. All right. Well, it is time for us to take a short break. When we come back, we will be here with our special guest, Dr. Alana Mcdonald, who's going to tell her all about her work in astronomy, outreach, and education. Don't go away. We'll be right back. Hello, everybody, and welcome back to the Astro Show. We're here with Dr. Alana Mcdonald from the University of Toronto. Alana, thanks so much for being here.
Hi, thanks for having me.
Yeah, it's our pleasure. Well, we like to start off the guest spots by asking everybody the same question, which is, what's the one question that you wish everybody would ask you, but nobody ever does?
So that's hard because people ask me a lot of very strange questions, especially when I tell people what my job is at a bar or something, which is great. But I think the one question that I really want somebody to ask me is, do you want to be the director of my planetarium? That would be super cool.
Nice. Well, stick around. We're building an observatory and a planetarium in Jackson, so maybe we can help you out with that.
Ooh, that's exciting.
Okay, so your last comment kind of caught my attention there. You said that you work at a bar. Tell us all about that.
Well, I don't work in a bar, but I go to bars lots, and then people ask me what I do in my life, and I say I'm an astrophysicist, and then inevitably the interesting questions begin. So
I thought you meant you did like science on tap, that kind of stuff.
oh, well, we actually do that too.
Oh, okay.
Yeah. Through the Dunlap Institute for Astronomy and Astrophysics here at the University of Toronto, we have re-begun our in-person astronomy on tap events. So pre some weird event that happened in 2020. I don't remember what it was. It wasn't that important, I don't think. Yeah, we used to have these astronomy on tap events where we'd have about 500 attendees. We'd hold maybe 3 or 4 a year, and with fun little talks and game shows and prizes and all sorts of fun stuff. And we just got the go ahead to start doing them again, and we're going to have our first one in a month exactly from today. So I'm very excited about that. So if you happen to be listening from Toronto, make sure to check that out.
Cool. What's the topic going to be?
We have a whole bunch of different topics. We haven't officially announced them yet, but we have someone who's going to be talking. So this is an exclusive, I guess. We're going to have
I mean, you don't have to if you don't want to. I mean,
no, it's cool. I think we're going to be having someone talking about cosmic horror, which is using astronomy and then also like Lovecraftian fiction to sort of tie up how learning more about astronomy makes you have more existential dread, which is always a good thing to have, I think. And then we have one talk about an interesting type of star, and then another talk about galaxies. So sort of the whole gamut of fun topics. We try to keep people on their toes with a lot of different things.
Nice. Yeah, I'm curious about that talk about existential dread and astronomy.
Yeah.
I don't know that I've experienced that. I actually feel quite at peace with like the vastness of the universe and my insignificance in it. That kind of like helps me sleep at night, actually.
Agreed. It's like you don't really have to worry about anything because like in the grand scheme of things, it really doesn't matter what you do because we are so insignificant.
Yeah, I mean, like we were talking about earlier, the sun is going to wipe out everything that humanity ever does.
If anyone who's watching has an existential dread from astronomy, we have just leveled it up for them.
Yeah, come on, guys, like forget about it, right? You don't have to worry about anything. Like, so I don't mean to steal the show from you, Alana. I'll just say one more thing and then I'll give it back to you. So I had a buddy in college who called himself a nihilist with compassion. And this is like the nicest guy in the world. And I said, Seth, what are you talking about? You are not a nihilist, man. It's like, come on, you're the astronomer. You know that everything we do here is going to be gone in 3.5 billion years. So nothing you do matters. Thus the nihilism. And I said, okay, well, what about the compassion? And he said, oh, tomorrow matters. And I really like that. Nihilism with compassion. So give up your existential dread about the universe and be a nihilist with compassion. There you go.
Yeah. And I've actually had this conversation with a lot of people recently for some reason, but the fact that that the universe is so vast, we don't really matter, nothing really matters. Sure, that is a true thing. It helps put everything into perspective, but it is true that we assign meaning to things that are important to us. And it's meaningful for us to decide what's important and decide how we want to live our lives. Even though it's us deciding it, it still means that there are important things because we want there to be important things. And I think that's sort of the key takeaway from all that. Don't just want to lie down and die. It's just like there is meaning in the universe if you decide to make some.
Yeah, I'm on the same page with you there. That's fantastic. So let's back up for a sec. I would love to hear about your trajectory, how you ended up getting into astronomy, and how you ended up on the outreach and public education side. And that's where I ended up as well. And so curious to hear about other people ending up in a similar position.
Yeah. Well, when I was a wee child, my dad is a musician. He's a composer. He He writes a lot of music. He also plays guitar. And his music has often been inspired by various different things like ancient Greek music, more recently like jazz and blues. But for a period of time, a lot of his music was inspired by astronomy. And so he got really, really into amateur astronomy when I was like 7, 8, 9, 10, I think. And he bought himself what I like to call his midlife crisis telescope, which is essentially this, I think he still has it in the backyard somewhere, but it's this 16-inch mirror with a 6-foot long tube, and just like took up so much space. But since I grew up in rural Quebec, like far away from a lot of city lights, we could see this amazing sky. And, you know, he showed me all sorts of things through the telescope, like the rings of Saturn and the moons of Jupiter and the Ring Nebula. It was really cool to see all of that, and that sort of inspired me to like learn more about astronomy. And then in high school, I went on a school trip where we learned about relativity and black holes, and there was a guy I had a crush on at the time who started talking about, you know, black holes and how, you know, space-time is warped by the presence of, you know, gravity. And I was just like, well, I kind of want to do that for the rest of my life. So then, you know, I just worked towards you know, doing a degree in physics. And then I went to grad school and did a PhD in astrophysics, studying the ripples in space-time that come from two black holes that are spiraling around each other. And that was really cool for a little while. And then probably in the 4th or 5th year of my PhD, I'm like, oh my God, research is really stressful and I don't think I like it. And just because like when you're doing astronomy research, it's hard to lose track, or it's hard to keep track of the big picture, right? So you're always thinking about, you know, like this little nitty gritty problem that you're dealing with, like how come my code won't work? Where is this extra number coming from? Why is this an order of magnitude too big or too small? Like, you know, it's a lot of hard work and late nights and yeah. And what I found I really loved was the big picture, like explaining what I was actually doing to people always super inspired me, or just explaining things about space to people inspired me. So I decided I wanted to do public outreach instead. And then, I mean, while I was in grad school, I got the opportunity to do a lot of that. I would do planetarium shows in our little 25-person portable dome. And I would, I for a few years ran the Astro tours, which was a graduate student-led lecture series. You know, once a month there'd be a lecture, and then we bring people up to the telescopes afterwards. And in Toronto, the telescopes aren't nearly as good as they were when I was growing up. But, you know, you still see some things in the sky. And yeah, and so then when I graduated, I was like, I don't know what I want to do with myself. So I did sort of jumped around, did various education related jobs, you know, some private tutoring. I was a consultant on a documentary project. I worked as, you know, at a math learning center for a little while. Eventually I got a job at the University of Toronto in the outreach department, in the math department, and was like running camps for kids and doing all sorts of cool math outreach. Then eventually I got a job back at the astronomy department where I graduated from, doing more instructional support kind of stuff, which is still a job I do a little bit, running these huge astronomy courses of like 1,500 students. And just recently, I had the opportunity to become the outreach coordinator for the Dunlap Institute for Astronomy and Astrophysics. So I've been coordinating outreach activities now in the department since beginning of July-ish. So it's been sort of a weird circuitous path, but I'm finding that more and more I'm getting to do the stuff that I really love, which is spreading the joy of astronomy amongst everyone.
Yeah, I mean, that's what it's all about, right?
Yeah,
that's
really
awesome.
is.
That's a great story, and I'm so glad that it's landed you exactly back where you want to be.
Yeah, it's funny. Yeah, I mean, I started off at the astronomy department at U of T and got inspired to do outreach here, and now I'm back at the same institution, being able to actually do that as my career, which is pretty cool, I think.
Yeah, that is awesome.
Yeah.
So you said you grew up in Quebec. If I'm not mistaken, there's a really cool astronomy facility there at Mount Magenique. Am I pronouncing that correct?
Megantic or
Megantic. Okay.
Megantic if you want to be French,
Megantic.
but
Thank you. I knew I was going to butcher that. That's the
that's okay.
Astro Lab, right?
Yeah. Yeah,
Have you been
it's a
there?
really, I have a couple of times. It's a really cool spot because it's actually on a dark sky reserve. So
Yeah, yeah.
they've made a deal where like for several kilometers around, there's no actual light that is allowed to be projected up into the sky, and so the sky is incredible there. So you just it's this mountain, well, not a big mountain, but it's a mount that you can hike to the top of in about an hour, and it has this beautiful view of the surrounding countryside and lots of forests and trees and stuff. And yeah, there's an observatory up there with like a public communication center, like a little science center where they have telescopes that the public can use, and then there's actually a research telescope up there as well, which I think is still used. Yeah, it is. It's still used for like actual scientific research because they do have very, very dark skies there. But it's I think a 1.5 meter telescope, somewhere in that range. So, limited what you can do with it, but it's still a very, very cool facility. And I think the first time I ever saw the Milky Way was at that facility.
Oh, that's
Just looking at
awesome.
the stars span across the sky is incredible. Beautiful
Very
spot.
cool.
If you ever get a chance to go, it's
Yeah, have you been there too, Valerie?
No, fun trivia. It is in the path of totality for the 2024 total solar eclipse.
Oh, very
It
cool.
very much
There's a
is.
good reason.
Man, now that would be a cool place to be.
Yes.
Yeah, I've never been there. I found out about it years ago when I was doing research, market research actually, for the facility that I've been trying to build in Jackson, Wyoming for the past several years. And they were kind of like the main case study that I used in order to just talk about the feasibility of doing something similar in Jackson.
Very cool.
Yeah, so yeah, I talked to some great folks there, and yeah, they're very helpful. And yeah, I would love to go there someday. And yeah, here for the eclipse, that would be super cool.
Oh yeah.
Although,
that would be
what's
amazing.
the weather prognosis there that time of year?
Well,
Is it?
it's on April 8th, right?
Mhm.
So
Yeah,
yeah,
that's
I
kind of what I
mean,
feared.
yeah, I think most of Canada is usually pretty cloudy and rainy that time of year, but you never know, we might get really lucky and
I
see
may
some.
do Texas instead.
Yeah, well,
Nick,
Texas is
is
likely.
Austin on the path?
No, it's West Texas, I think. West Central Texas.
Okay.
I think we get hit by totality, but I don't know if we get the optimal time. There might be towards one after the other. Let me look that up though.
Okay.
Yeah, I'm just looking now. I haven't looked
Oh,
in Texas.
Party at Nick's house for the upcoming eclipse.
I think it's a party at my friend's ranch is really where you want to go with that.
Oh, okay.
Oh yeah, Austin is right on the edge.
On the edge.
Like it is in totality. You will see totality, but it is, if you go a couple miles out of town, you won't see totality.
Right. Yeah. So go find your friend's ranch. That's a little bit to the west, right?
Yeah.
Cool.
That's something very frustrating about that eclipse, is that Toronto is this close from the path of totality. Like if you went 4 kilometers south into Lake Ontario, then you would be able to see the eclipse. You'll be able to see like 99.93% in Toronto, but that's not totality.
Which is nothing.
So,
Yeah.
well, it's a thing, but it's not like as special.
Speaking of prophecy, I prophesied that there may be some boats out that day.
One or two.
Yeah. So Alana, let's see, you told me earlier before we got online that you mentioned it earlier during the show that you study gravitational waves.
I did, yes.
Yeah, so tell us a little bit about that.
Sure. So for my PhD thesis, I studied gravitational waves, which are essentially ripples in space-time caused by very massive objects that are accelerating through space. So the example that I studied was you have 2 black holes, which are these infinitely dense, crazy, massive objects that are spiraling around each other. And because they're gravitationally interacting and moving around in space, they actually give off these like ripples in space-time that propagate out into space. Basically what it translates into is a slight lengthening and shortening of space that sort of comes out. So I think of a good analogy is like you have a water bug on a pond, and like when it's just sitting there, you could have a perfectly still pond, but as soon as it skitters around or something, then you get ripples on the pond. It's sort of like that idea. And so we actually have some detectors which have detected gravitational waves, which is super cool. And so these detectors called LIGO in your country. There's one in Washington and another one in Louisiana. And they're very, very sensitive instruments that can detect these very, very minute changes in length. So if a gravitational wave goes through it, then it detects this very slight change in length, and you know that some sort of signal went through. And so when I was studying gravitational waves, it was I graduated in 2013, and the first detection of a gravitational wave was in 2015. So it was kind of interesting to be in this situation where it's like, these things might exist. However, we're not sure. But here, have a PhD thesis.
Good vindication,
so it was,
right?
Yeah, I mean, it could have just been like, well, we made these very expensive detectors, and it turns out that Einstein's theories of relativity were totally wrong, and these gravitational waves don't actually exist. But
seemed unlikely. Yeah,
it seemed unlikely based on what we knew already.
Yeah.
But yeah, no, it was so the day that the first gravitational wave detection was made, I had just started my job at the math department at the University of Toronto, and I was like, boss, I'm sorry, they just detected the first gravitational wave, and I can't pay attention to work right now. I'm just going to look at press releases all day. And she was very understanding. She's like, well, maybe we can put a math outreach bent on this and make it like so it's actually your job and not just you messing around. So I was very appreciative of that.
There's some super cool math with the LIGO detector. I mean, like just like the extremes that they had to go to make that thing work.
Oh, 100%. It's an amazing feat of engineering.
Yeah.
Like you think of like, oh, astronomy, it's just like looking at stuff in space and what are you actually contributing to humanity? But then you can point at something like LIGO, where it's like, oh, we just had to develop the most stable possible mirrors in the world. Oh, we just had to like develop a perfect vacuum chamber that could be like 4 kilometers long. Oh, we just have to develop like the most power. We just have to develop the most powerful lasers ever. Like, no big deal.
And make
no
it
technology.
all work together.
Make it all work together. And not even to mention like the software that had to be developed to match templates of what gravitational waves are supposed to look like to the actual signals that were detected, so you could actually see these things. So it was overall like a huge crazy feat of engineering and computer science, and is.
And then my understanding is that like the first detection was like day 1 when they actually came online.
Yeah, it was very fast after so and it was like this perfect signal too, and it was exactly the type of signals that I had been studying in my PhD thesis. So like cool. I was mostly for my thesis determining how precise different models of what gravitational waves were supposed to look like had to be for these detectors. And the type of model that I mostly looked at was for black holes, which are the same mass as each other, and they're spiraling in towards each other, and then they eventually merge, and you get this like big burst of gravitational radiation. And the first detection was essentially one of these equal mass systems where it is very, very loud and very standard. Maybe not standard, but like it was the type of signal we were sort of like the easiest case scenario, which was nice.
There's this incredible interview on Veritasium with one of the head scientists at LIGO, who talks about his disbelief when this signal was first found a day after the detectors came online. His story is that apparently he didn't believe it for a month. They basically like tore the place apart looking for sabotage and other things
Yeah.
that were like, could have possibly like made this fake signal because it was so perfect.
Yeah, no, exactly. Well, and I know that in order to test the pipeline to make sure that everything was working properly, sometimes they would just insert an artificial signal
Right.
so that, you could be like, oh, okay, well, is this signal real or not? We don't know, but we have to make sure we're doing all the tests properly to see if it is. And I remember there was like one that appeared in the pipeline at some point, and they were just like, oh, is it real? And then somebody opened an envelope. It's like, oh no, it's not real. But they had to do those little tests to sort of make sure everything was working properly. But yeah, I mean, there's a huge like recent history of huge discoveries in science using very precise instruments where it turns out not to be real. So I can understand like wanting to wait a month until you've done all the checks and balances and made sure you've double checked everything before like saying, oh yes, we have officially detected a gravitational wave.
But which one were you just referring to a second ago? I was curious.
Something maybe about faster than light neutrinos at CERN, or maybe having discovered certain types of magnetic fields in the cosmic microwave background with what was it, the South Pole telescope, I think.
Nick might know
Radio
something about that.
Oh yeah, I know all that. That was a different type of gravitational waves, primordial gravitational waves. But yeah, they didn't. Turned out it was just our galaxy.
I mean, it's still not so bad, but
it wasn't very sensitive measurement. The neutrino one was a little more embarrassing because I think that was just a loose cable, which wouldn't be the first time either. But
yeah. Nick, what is the? Oh, sorry. I was just gonna ask Nick if you know what the status is of the Simons Observatory.
I definitely know the status of that. No, well, yeah, I'm got Slack messages blowing up over here because we've got the first camera cooled down, still in San Diego, but it's going through its kind of final test before we ship it down to Chile early next year. So that should be on sky within the next 12 months. There we go, getting that year prediction time scale.
Hey, there you go. All right, there's some prophecy for you. Yeah,
we will have more CMB photons to play with in a year.
Yeah. Not so bad. Cool, man. That's great. I wish you guys the best in that. I hope that all works out and that we actually get some polarization for the cosmic microwave background radiation. That'd be sweet.
That'd be really cool.
Yeah, and we got actually, speaking of Toronto, we have a bunch of people out there working on it.
I think so.
Yeah, the big one I can remember is Renee Hosek is up there. But yeah.
Oh yeah. Her office is 2 doors down that way.
Hey, so I said hi. Great.
I'll say hi for sure.
Small astronomy world.
Sure is.
Well, Alana, we've got a few minutes left. Curious if you have any words of wisdom to leave us with before we close this evening.
Ooh, no pressure.
It could be anything. No pressure. Something that you've learned through your trajectory of getting where you are, or something you've learned professionally, or whatever you'd like. Or not.
Yeah, I don't know. Well, I think the story of my life so far has been to just do stuff you like. So if you're interested in astronomy, if you're interested in anything else, you should just start doing it or stuff related to it, and eventually you'll end up somewhere where you're really happy. So that is my life advice to just about anybody. It doesn't have to be for astronomy, but
that's fantastic.
It's a good thing too.
I really like that. And I'd actually like to put a plug in for your dad for his midlife crisis. Buying that telescope was a sweet decision, sir. That is a bona fide, wonderful way to have a midlife crisis. I mean, backyard astronomy is where it's all about getting interested in science. So.
Yeah, better than a sports car.
I was going to say cheaper than a sports car too, but it probably depends on how many accessories you buy.
Yeah.
Yeah. He did have a lot of eyepieces and filters, and they just sort of collected.
It can add up really fast, actually. And I the last show and this show, I forgot to do the "What's Up, Dr. Sam" segment. I don't know why I keep missing that. But like this week's was actually about some backyard astronomy stuff. And so like I think it'd be fun to like to do that in honor of your dad here. So Gavin, if we can bring up the "What's Up, Dr. Sam" Jupiter slides, we can end with that. Oh, there you go. All right, so this is not what I saw in my backyard last night. This is the James Webb Space Telescope image of Jupiter that just came out in infrared. Amazing, right? We have not seen Jupiter like this before. So thank you, James Webb, and the thousands of people and 30 some years of work that went into producing a James Webb Space Telescope to bring us those incredible images. I went out last night and got these images. The one on the left is Jupiter, which is up in the sky right now. On September 26th, Jupiter was at opposition, which means that it's the farthest in the sky from where the sun is. So it was the opposite end of the sky. So on September 26th, the sun was going down and Jupiter was rising. It was super cool. And Jupiter's a little bit higher in the sky now when the sun sets, but it's still just over the eastern horizon. You can see Jupiter from like pretty much anywhere, even like in a really big city. You can go out and look to the east after sunset and see Jupiter. It's going to be the brightest thing there unless there's a plane going by. So it's the brightest thing that doesn't move.
Well, I was gonna say, you can even see it despite the full moon, which you can see
even when the full moon is up. Yeah, I mean the full moon is brighter than Jupiter. But even when the full moon is up, like it was a few days ago, you can actually see the glare of the moon just off the edge of the picture that I took last night. So even with the full moon up, you can still see Jupiter shining brightly in the eastern horizon this time of year. And with a pair of binoculars, I was able to hold my cell phone up to the pair of binoculars and get that first zoomed in image where you can actually see Jupiter's 4 moons. So you don't need a lot, just like a basic set of binoculars. You can see Jupiter's 4 moons, including Europa that we talked about tonight. And then if you have a telescope, the one I used last night was just an 8-inch aperture telescope, nothing like Alana's dad's, a 16-incher, 4 times the light collecting power than what I was using last night. That's a big hunk of glass. That's a nice light bucket. But we just have an 8-incher here where I am, and I just held my smartphone. Yep, thank you, Nick. Still a good piece of glass. I just held my smartphone right up to the eyepiece and was able to get that picture of Jupiter. So not quite as good as James Webb Space Telescope, but I was also under the thick blanket of the Earth's atmosphere at a few thousand feet compared to about 1 million miles out in space. So,
and you don't see an infrared.
And I don't see an infrared. Darn. But yeah, that's what's up. So Jupiter was actually at its closest approach last month, closer than it had been since like 1963, I think. And that's because the orbits of the planets are not perfect circles. They're ellipses, almost perfect circles, but not quite. And so every time we're making a lap around the sun, and the other planets are as well, in different amounts of time. We get some nice alignments when planets get at close approaches, and Jupiter was just there a few weeks ago. Now it's a little farther away, but still really bright. So go out and see Jupiter on the eastern horizon of your sky this evening. Should be happening pretty soon. And thank you, Alana's dad, for bringing that back to the forefront of my thinking. So I didn't forget to do that for like the 2nd time in a row.
Let him know.
Yeah, please do. What's his name?
Andrew McDonald.
Andrew McDonald. Well, he must have been pretty psyched that you got into astronomy, right? He probably took credit for that.
Oh yeah, totally.
Well, Alana, it has been a pleasure. Thank you so much for joining us this evening. We've got a thank you gift for you, and Maggie, our operations director, will connect with you for that. So we really appreciate your time, and thanks for joining us.
Thanks so much for having me. It's been a blast.
Yeah, it's been fun. Thanks to the co-stars, as always. Wouldn't have the show without you, so thank you so much for your time as well. And to the other folks behind the scene, Gavin, our stream master, Wyoming Stargazing Board of Directors, all of our supporters, and all of you out there watching. We'd love to hear from you. So give us a ring next time, or chat your questions or your answer to that trivia question of when Neil Armstrong made that quotation. If you do that, you will get a free astronomy print from Wyoming Stargazing. And there are some really cool ones that we have to offer. So if you can figure that out and give us a source, we will give you an astrophotography print. So make it happen. We'll see you again in a couple weeks. Until then, be well, and don't forget to look up. We'll see you next time. Bye.